So this is test ID 2. The subject is communications, and we are discussing question number 43. Now this question is again related to PCM, pulse code modulation. It is given that in a pulse code modulated system, the step is fixed to 1 volt. That is, the delta, the quantization step is fixed to 1 volt. The rate of message variation initially at the initial time, that is the rate at which the message is changing, which is d by dt, let x of t be the input, which is an input to the PCM. dx by dt is said to be a very small number, is very small. It is found that the message peak to peak initially is 0.9 volts. It is given that the message peak to peak is 0.9 volts. What happens to the output during this time, and what is the solution to this? This is the question. Now, we know that the quantizer characteristics are not explicitly given in the question. The quantizer characteristics are not given. So, but what is given is step is 1 volt, which means when the input is between 0 and 1 volt, if the input is between 0 and 1 volt, the output is always some constant value. We do not know exactly what the quantized value is. It's not given in the question. It can be anything. It can be 0.5 or it can be 0 or it can be 1, depending upon the quantizer, depending upon the quantizer characteristics. Since that is not given, what we can say is it is a fixed DC value. Now, if you look at the choices, it says MQ of t is 0 and can be eliminated by thresholding. Since the exact quantized value is not given, we cannot say A is the right choice. Now, B says MQ of t is a fixed DC voltage. Yes, that is right. But it also says, the question is, what is the solution to this? How do you fix this problem? How do we fix this problem is by reducing the quantization step size. Delta, which means is larger now, we need to reduce delta. And how do you reduce delta? By making it smaller. It should be made smaller compared to 1 volt, or otherwise the other procedure is companding. What you do is you take the input and increase the input amplitude. You pass the input signal through a characteristics which is actually a nonlinear characteristics, such that when the input is at higher voltages, we need to get when the input is at lower voltages, we map it to a large output range which is with higher output values. When the input, okay, this characteristics is not properly drawn, but what I'm trying to convey here is that if the input is small, they should have a large range. Output should be large because the input is in this smaller voltage range. Now, this is what we call companding. The smaller input voltages are boosted. Now this operation is called companding, and choice B actually says both these things, and hence choice B is the right answer.